Going to take a UPSC crash course. First topic is interior of Earth. We have interior of Earth, three things: outer core is crust, mantle, core. So we have discussed each and everything. First is crust, continental crust, two things: continental crust and oceanic crust. We have Cl, we have Sima. This is less dense, this is more dense. What is Cl? Cl plus silica plus aluminium. What is Sima? Silica plus magnesium. This is crust. And the second layer is mantle. Mantle. Two things. The first thing we have to know about mantle is it occupies 83% of volume of Earth. 83% volume of Earth. And we have two things: upper mantle, lower mantle. Upper mantle is called Asthenosphere. Asthenosphere, which is zone of low velocity. Why it is called zone of velocity? Because the P wave travels slow. The earthquake wave, P wave, which travels slow, and this asthenosphere in semi-molten state. Semi-molten state. And that's all about mantle. And we have core. Two things: inner core, outer core. Inner core is solid, outer core is liquid. Why solid? Two things: superincumbent load, and the second thing is superincumbent load. Second thing is knife, presence of knife, nickel plus iron, which makes this as solid. This region is solid. And we have an analytical part: crust, mantle, core. The temperature keeps on increasing when you move downwards. But the temperature increase is highest in this crust, whereas the temperature increases at the decreased rate in mantle and core. Why? The reason is in the crust we have radioactive materials, radioactive disintegrations, so which makes this layer the temperature increases at the highest rate. That's all, friends. So next topic we are going to see is about volcano. There are three types of mechanism in volcano. One is convergent or destructive plate boundary, and the two is divergent or constructive plate boundary, and third is conservative plate boundary. First is convergent or destructive. So the mechanism is we have oceanic plate, we have continental plate. The oceanic plate gets subdued over the continental plate, so this layer gets melts. And it forms lava, magma. This layer gets melts and forms magma due to the enormous pressure which comes out as lava. So this type is very explosive. You can find this in a Pacific ring of fire region, and or it is also called a circumspecific belt, and also in mid-continental belt, in and around India, mid-continental belt. So that's all about convergent. So next we are going to see about divergent. Divergent is nothing but we have two plates. The two plates diverge each other. So due to the thermal convective current, the magma which comes upward, and it stays here. So this we can see in mid-Atlantic ridge. Mid-Atlantic ridge. There is a notion that Atlantic Ocean is increasing, Atlantic Ocean is expanding, and the Pacific Ocean is shrinking. It's because due to the divergent plate boundary, Atlantic Ocean, it's get expanding, and this magma, gets expanding. Whereas due to the convergent, the Pacific Ocean gets shrinked. So this is the reason. And we have a third type called conservative. Conservative is nothing but the two plates slide each other. There's nothing important. That's all about volcano. So the next topic we are going to see is earthquake. What are the causes of earthquake? Is plate movement, volcanic eruptions. Third is undermine explosion. Fourth is dam construction. You can see dam construction in Maharashtra, Queen in Maharashtra. We can see the dam. Because of the dam construction, the earthquake occurred. So the next is mechanism of earthquake. So there are two plates. The heavier plate substitute over the less dense plate. So this region gets broke and the sudden force is liberated, and this is known as this sudden force is known as earthquake. So what are the waves? Waves associated with earthquake is P, S, L, primary wave, secondary wave, and surface wave. This is a longitudinal wave. This is a transverse wave. It passes through solid, liquid and gas. This passes only through solid and not liquid or gas. It is a longest wave and a destructive wave. Why L wave is a destructive wave? Because it passes through the entire Earth surface, so it destructs all the buildings and the surface of the Earth. And of waves. So we have Earth, core, focus. The point above focus is known as epicenter. We have waves coming from the epicenter. So this is 103 degree, 145, 103. So 103 to 103, shadow zone of S. 103 to 145, shadow zone of P. So this fully shadow zone of Z, because the outer core is liquid. S wave cannot pass through liquid, so we have S shadow zone. This is shadow zone of P. Why? The water, the liquid which is present, which gets divided, the waves coming from the P waves, it gets refracted and it will present here only. So this is called shadow zone of P. That's all about mechanism of waves. In our measurements, how intensity is measured, intensity or magnitude. So magnitude is measured by Richter scale, and we can see that magnitude is by MR, and intensity is measured by Mercalli scale, IM. Mercalli scale, IM. So Mercalli scale, why intensity is, you can know the quality of damage, how damage is caused, we can know by means of intensity, by measuring the intensity. For example, if earthquake occurs in desert, so no damage. Whereas it is in a most populated regions, so more damage, so intensity is more, so which is measured by Mercalli scale. So distribution of earthquake, that is ring of fire, which is also known as circumspheric belt and mid-continental belt. Three types of rocks: igneous rocks, sedimentary rocks, metamorphic rocks. So first we are going to see about igneous rocks. Igneous rocks is the rocks formed by crystallization and solidification of magma. It's very important point. This is also called as parent rock. It is of two types: intrusive, extrusive. Extrusive type. Intrusive is the magma formed beneath the surface of the earth. It is called intrusive. Extrusive is at the surface of the earth. Example is granite, laccolith, batholith, sill, dike. So all example. Here the example is granite. This is basalt and grabo. What are the characteristics of igneous rocks? This is formed due to lava, and it is suitable for cotton cultivation. And third thing is no stratification. That is no stratification. There is no shale. There is no stratification and no fossils. This is all about igneous rocks. Next is sedimentary rocks. Sedimentary rocks is also known as secondary rocks because it is derived from the igneous rocks. It has a stratified layer. That is, we have gas. One layer is gas, another layer is coal. So it has stratification. And second is we have fossils. This is fossified layer. Igneous rocks don't have fossil because it is too hot. It contains lava. It is too cold. So igneous rocks don't form. Igneous rocks don't form the fossil layer. There are three types of sedimentary rocks. One is mechanically formed, another one is chemically formed, another one is organically formed. So example of mechanically formed is sandstone, limestone, dolomite, etc. Organically formed, peat, lignite, bituminous. Whereas chemically formed is gypsum and rock salt. So final is metamorphic rocks. Metamorphic rocks, when a rock is placed under pressure, temperature, we form metamorphic rock. Example, limestone is a sedimentary rocks. When applied pressure and temperature, it will change to marble, which is a metamorphic rock. So we have so many examples like this, and that's all about rocks. Orogenesis, which is nothing but mountain building. Oro is mountain, genesis is origin. So how mountains are being created. The first one is fold mountain. How fold mountain is created? There's two plates. Due to their convergent forces, mountain is formed. Example, all the fold mountains, for example, example is Himalayas, Andes. So all the major mountains in the world are all fold mountains. The second mountain system we are going to see is block mountains. How the block mountain is formed? This is the layer. This is the Earth's surface. We have two faults. This layer comes down. This is known as Rift Valley. How is this way? If this comes down, this is Rift Valley. Or else, if this goes up, this is called host. So in simple diagram, we can say that this is host or block mountain, and this down region is graben or Rift Valley. Example for host mountain is Vindhya. Vindhya is the only block mountain in India. Graben is Rift Valley, African Rift Valley, Rhine Valley, etc. The third thing we are going to see is about residual mountain. Residual mountain is formed due to the erosion. Example, Nilgiri, Rajmahal Hills and Girnar. So these are examples of residual mountains. And the fourth one is volcanic mountains. So volcanic mountains are found in Cotopaxi, Kilimanjaro. So these type of mountains are also volcanic mountains. So all about geomorphology. We are going to see a next chapter known as atmosphere. So let me ask a question, that if you have a sun, we have a mountain. If you climb up the mountain and we move towards the source, the temperature is getting decreases. Do you know what is the reason behind this? It is because the Earth atmosphere is heated up from bottom to the top. For example, this is sun, we have Earth surface, Earth, we have atmosphere. The sun rays reaches the Earth atmosphere by means of short wave radiation. It penetrates to the atmosphere and it gets reflected, and now this is long wave radiation, and it is trapped by the atmosphere where you have greenhouse gases, the water vapor. So the long wave radiation is trapped by the atmosphere, and again it is reflected back into the atmosphere, which heat the Earth atmosphere. So that's why when you move from bottom to top, the temperature is decreases. Okay, fine. So we have to see what is albedo. Albedo is the sun rays which is emitted from the Earth's surface, is known as albedo. The albedo of snow is greater than that of cloud, is greater than that of water, is greater than that of land. So this is very important. Study this. And we are going to see about the layers of atmosphere. What are the layers of atmosphere? First one is troposphere, second one is stratosphere, third is mesosphere, fourth one is ionosphere. So troposphere, all weathering take place here. We have normal lapse rate, that is normal lapse rate. When you move upwards, when you move up the atmosphere, the temperature decreases by 6 degrees Celsius per kilometer. So this is normal lapse rate. And we have troposphere. In stratosphere we have ozone. In this layer the temperature increases. Why? Because temperature increases or constant. Why? Because of ozone. The ozone which is present, which absorbs UV rays. So this layer gets heated up by means of ozone layer. The ozone is getting depleted by chlorofluorocarbon and also the jets flying in this region, which releases nitrous oxide, which depletes the ozone. This is stratosphere. This is all about stratosphere. Mesosphere, we recorded the lowest temperature, and meteors found here. Ionosphere, highest temperature were used for radio communication. For example, this is Earth's surface. This is an ionosphere. The rays gets deflected. So this is all about. So next we are going to see is about pressure belt. So this is equatorial low. There are four belts. This is equatorial low pressure belt. This is subtropical high pressure belt. This is subpolar low pressure belt. This is polar high pressure belt. So first we look into equatorial low pressure belt. So equatorial low pressure belt is of thermal origin. Why? Because high temperature. Equator which has high temperature. So obviously low pressure. High temperature, low pressure, warm air rises, cools, precipitation. So in this region we have a 4 o'clock rainfall. That is, this happens high temperature, morning high temperature, so low pressure, warm air rises, cools, precipitation, so 4 o'clock rainfall, so thunderous rainfall. This region is also called as doldrums, which is known as belt of calms. The wind flows in this region is very calm, so that's why it's called as doldrums. And next we have tropical high pressure belt. So in tropics also we have maximum temperature, but also we have maximum temperature, but also we have high pressure. You should have low pressure. Why high pressure? Why then high pressure? It's because the rotation of the earth which makes the warm air cooler. So subsidence of air, the warm air rises, again cool, so cooler subsidence, so which results in high pressure. So this is the reason the desert forms in the tropical region on the western side of the continent. We have a continent, the western side we have desert. This is one of the reasons why the desert forms in the subsidence of air mass. Okay, this region is also known as a horse latitude. It's also latitude. Just make a note. This is also a horse latitude. And subpolar low pressure belt here, so cool, so you should have had high, but we are having low pressure. Why? Because rotation of the earth. This is of thermal origin, high pressure, very cold, so high pressure, no problem at all, high pressure belt. We're going to see is about the wind. So before going to wind, we are going to see about Coriolis Force. What is Coriolis Force? The Coriolis Force is created by the deflection of the earth, in which the wind deflected to the right in the northern hemisphere and deflected towards the south, diverged towards the left in the southern hemisphere. So this is called as Farrell's law. This you should bear in mind because it can be asked as a question. What is Coriolis Force? So next we are going for a wind system. So this is equatorial region, equatorial low pressure belt, subtropical high pressure belt, subpolar low pressure belt, and polar. This is called as this region, and this region is called trade winds. This is trade winds. So northeast trade wind, southeast trade wind. So what is special about the trade winds is, see, if you have a continent here, it brings rainfall to this region, that is to the eastern part of the continent, whereas the western part of the continent is a desert, because only the moisture is poured as a rain here. The moisture less air which flows through this, which is a dry air which flows through this, which becomes a desert. So this region is okay. So there are three reasons for forming a desert. 3 reasons. First is subsidence of air mass, and the second is the trade wind, so which brings the dry air, and the third is the cold current. The cold current which is present in the western coast, of example Peruvian current. So these current will form a desert. So that will be seen in hydrosphere. So next is westerlies. On peculiar westerlies is known as westerlies flows from subtropical high pressure belt to subpolar low pressure belt, that everyone knows, and it is otherwise known as westerlies. Westerlies is otherwise known as 40 degrees south or 50 degrees, that is striking 60s, furious 40s, furious 50s. So these are the name which is indicated for westerlies. Why that's so on the western, that is also on the southern side. So why it is 40 degrees southern hemisphere? Because we have more oceans, more seas in the southern hemisphere compared with the northern hemisphere. So the westerlies in the when the southern hemisphere is much more stronger compared to the northern hemisphere. That is why this question is asked in the UPSC. Please bear in mind, the southern hemisphere is called as 40 degrees south or something like that. Just bear in mind that. So next we are going to see is about local winds and that land breeze. So what is land breeze? It's also known as offshore winds. So this is land, this is sea. When a wind blow from land to sea, that is land breeze, land to sea, land breeze. So during night the sea will be warmer, so high temperature, which means low pressure, here high pressure, so wind always move from high pressure to low pressure, so that's why land breeze, from land to sea. So sea breeze reverse occurs. So during day land heated quickly, so here high pressure, high temperature, so low pressure, here high pressure, so obviously from sea to land, so sea breeze. So the next topic is cyclone. Cyclone, first thing we have to remember is CAN. What is CLAN? C is cyclone, anti-clockwise northern hemisphere. In the cyclone is anti-clockwise northern hemisphere. So this way northern hemisphere, south. That's all cyclone. And cyclone is of two types: tropical cyclone and temperate cyclone. So in tropical cyclone, the center region is called low pressure, which is called as I, surrounded by high pressure. So this is low pressure surrounded by high pressure. So when India always always you have a high temperature, so we have low pressure created, so and a cyclone is created. It always move from east to west. Cyclone always moves from east to west. Whenever it reaches the land, it loses its potential. Why? Because the cyclone gets its energy from the ocean. So whenever it reaches the land, the energy is cut off from the ocean, so it loses energy. So this is all about cyclone, tropical cyclone. And next is temperate cyclone. Temperate cyclone is nothing but two air masses, there is warm air, cold air, converges at a certain point, a front is formed, so that is called temperate cyclone. So nothing more we need to know. This is what enough. What is temperate cyclone is enough. So what are the differences between tropical and temperate cyclone? What are the differences between tropical and temperate? Tropical cyclone is small in size, whereas the temperate is larger in size. Speed wise, this is more speed, this is less speed. This is circular in shape, this is elliptical or V-shaped, and this occurs in 10 to 35 degrees latitude. This is 40 to 50 degree latitude. And the most important point is it occurs only in ocean. It occurs in land as well as in ocean. So it occurs only at 27 degrees, and continuous supply of energy is required from the ocean. So continuous supply of energy is required. This does not require like this, because it is two air mass converges. So temperate cyclone does not require that. So this moves from east to west, this moves from west to east. So this is all about cyclone. Thank you. We are going to see is hydrosphere. So first we are going to see about the continental shelf. So shelf is slope, this is plane. So continental shelf, continental slope, continental plane. This is the land surface. So this will be the ocean. So this is shelf, slope, plane. So first continental shelf. First we are going to see origin. How continental shelf origin? Origin is due to erosion of plates, land, subsidence of land mass or plates, submergence, sedimentation. So there are various theories. It's all telling about the origination of continental shelf. So one particular thing about one thing about the continental shelf is, whenever you have a mountain system, the continental shelf is narrow. When you have a coast, it is wider. A coast or plain, it is wider. But the exception is India. In India, we have Western Ghats. It should have been narrower, but we have a broader continental shelf. As you can see in the map, it is broader. Along the plain, along the coast, it is narrower. So only exception is India. So world largest fishing ground, richest fishing ground is present in continental shelf. Why? because cold current plus warm current means, whenever warm current and cold current means, we have a largest fishing area. For example, the Grand Bank and the Newfoundland, which are present in that region. Next is continental slope, where we have no deposits, will be no deposits, because as it is slopey, and it reaches have trenches, canyons, etc. The next topic we are going to see is salinity. What are the factors affecting salinity? Is evaporation and precipitation. When there is a high temperature, high evaporation, so high salinity. So when you have more rainfall, less salinity. So equator, tropics, equator. So maximum, the equator, it has higher temperature. So as you think, so it should have more salinity, but it is not. The tropics which has higher salinity. Why? Because in equator we have high temperature plus high precipitation, that is 4 o'clock rainfall, so which dilutes the salinity, whereas in tropics high temperature plus low rainfall, so maximum salinity. So that's all about salinity. One more thing, we have maximum salinity in Lake Van, Turkey, and Dead Sea, Israel. So next is ocean current. What are the factors affecting ocean current and what are the factors modifying? What are the factors affecting is PDS, which is the current, the water flows from low to high. TR, water flows from high to low. What is P? Pressure, density, salinity. T is temperature, R is rainfall. So PDS is from low to high. Temperature and rainfall, high to low. Water flow from high to low. Let me explain this. For example, we have high rainfall, high rainfall. We have high rainfall. Here we have low rainfall. So high rainfall, high water. So water move from high rainfall to low rainfall. So this is a current. So in that way you can form other things also, the temperature, density. So what we have to remember, this PDS, this is low to high, L to H, TR, H to L, that's it, you can form it. So what are the factors modifying ocean current is bottom relief, rotation of the earth, seasonal variation in the wind pattern or the atmospheric circulation, so that also modifies the ocean current. Pacific, what are the different types of ocean currents? In Pacific Oceans, warm, cold. So what are the currents we have? The first current we have is north equatorial current, Kuroshio current, Tsushima. In the cold current we have Oyashio, California, Peru. Very important is Peru, which is also called as Humboldt current, which is very much plays a role in El Nino. And then Atlantic Ocean we have Florida, Norwegian, Brazilian. Here Labrador, Benigula, Falkland, Canaries. See, this you can see in the map itself. Elaborate will be given in the map, so you can refer the map to know more about current, different types of current. So let me explain. Next thing is what is upwelling zones. Upwelling zones are zones where the current bring nutrients to the upper surface of the ocean. So the nutrients will be at the bottom of the ocean. The current which brings the nutrients to the upper surface, so that so many fishes will come and feed the nutrients, so which will be rich in fishing grounds. And again, other question is, no cyclone is formed in the west coast, only in east coast we are forming the cyclones, tropical cyclone. So what is the reason behind this? Because in the west coast we always have a cold current. The cold current, for a temperature, for a cyclone to be formed, we need to have 27 degrees Celsius, but the cold current dilutes the temperature, so we have always cyclone on the east coast. And again, desert, whenever you have a cold current, we always have a desert when you have a trade wind, the subsidence of air and all the things. Thank you. For next class will be economics.